This issue for me goes back a little more than 50 years. As none of you remember, but some of you may know, 50 years ago, population growth played essentially the same role in the public discussion that climate change does now. That population growth was the looming catastrophe which would do horrible things to the world unless we did drastic things to stop it. And I got interested. I was asked by the Population Council to write a piece from a pro-market standpoint, which nobody was doing, analyzing the population issue. And I did. It's on my webpage if people are curious. And what I was trying to do was, as an economist, to think of this as an externality question. When you have one more child, what negative and what positive effects do you have on another person, on other people? And I tried to figure out what the net externality was, because everybody was talking about the ways in which population growth made the world worse. It seemed to me there were also ways in which it made it better, and that what you wanted was the net. And I concluded that there were both positive and negative effects, and they were sufficiently uncertain that I could not sign the sum. I could not say whether on net it made us better off or worse off. We still don't know, of course. But what we know is that what was the conventional view then was wrong, because that conventional view made predictions. In particular, it predicted that unless something drastic was done to hold down the population of especially poor countries would get hungrier and poorer. In fact, the population of poor countries continued to grow, still growing in Africa, and poor countries got strikingly less hungry and strikingly less poor. So in that sense, they were wrong. Whether I was right, we don't know. So when climate became an issue, I looked at it from that standpoint. That the previous experience raised two things with me. One of them, that you really wanted to think about net externalities, not about whether there were any negative effects. And the other was that you could not trust the fact that you were told all the experts knew what the answer was, since that had been the case the previous time, and I knew that they had been wrong then. So there are basically, I think, two ways of trying to approach the question of whether climate change is bad for us, and if so, how bad. One of them is a priori. You could say, are there reasons to expect that climate change will make us substantially worse off? And actually try to estimate the various effects and what their costs and benefits are. The a priori case is pretty weak. Climate was not designed for us, nor were we designed for it. That humans live across a wide range of different climates. The Earth's climate has changed pretty radically over our species' history because there have been recurrent glaciations followed by interglacials. The only a priori argument I can think of is that humans are currently optimized against their current environment. That when you're deciding what kind of house you want, the question of how hot it's likely to be may affect whether you want air conditioning, insulation, and a furnace, and so forth. When you're trying to decide what crops to plant, you ask what are the crops that are best in my current environment, and so forth. So we have, for the economists in the room, sunk costs in optimizing against our current environment, and they're different in different parts of the Earth. So if you change the environment either hotter or cooler, there are going to be some negative effects because what you now have is not optimized for your new environment. And I think those could be substantial for fast change. But if you look not at the sort of newspaper oratory, but the actual estimates the IPCC makes, it looks as though what we're talking about by the end of the century is a temperature 2 or 3 degrees higher than the temperature was a century ago, roughly, a little more than a century ago. That's a pretty small change over roughly 100 years. In fact, over more than 100 years, since part of it's already happened. The sea level rise, the current estimate suggests that by the end of the century, sea level will be about ½ a meter higher. Might be more than that, might be less than that, but somewhere around there. The rough figure, I happen to have come across a figure for the U.S. East Coast of how much sea level rise changes the coastline. And the rough rule of thumb is that the coastline moves 100 feet for every foot of sea level rise. So that means that if sea level goes up by ½ a meter, the coastline will shift, that particular coastline will shift by about 50 meters, which if you think in terms of a map is a pretty trivial change. It's not as if we're losing large amounts of coastal land. Now, it'll be more than that in some places. I think when I tried to use a online source that let you look at the effects, it looked as though the Nile Delta was about the most vulnerable place in the world. And there you really would lose noticeable amounts of land. But on average, you're talking about very small effects. And those effects over that long a time, it seems to me, are not likely to involve very substantial costs that after all, farmers in the next century are going to change their crop variety probably a dozen times as people's tastes change, as new varieties are introduced and so forth. And at least in the US, maybe not in Europe, the average house probably won't be around 100 years from now. It will have been replaced by something else. And if the climate is a little warmer, it's going to be a little less likely to be insulated to keep it warm, a little more likely to have air conditioning or insulation to keep it cool. If it's very near the coast, it'll be rebuilt 50 meters farther in. But you're not talking about very large effects. On the other hand, there might be large effects for other species, because I've been talking in terms of human optimization, which is done by sort of rational choice, but other species are optimized by evolution. And it is at least possible that for some of those species, even a change that slow might have serious costs. I don't think there's good evidence that it would, but it's by no means impossible, especially if you think of something like trees. Trees evolve very slowly because they have long generations, and they move very slowly. They do move if you think about the forest area dying off at one edge and spreading at another edge, but that's a very slow process. So there certainly could be costs of that sort. But as I say, I think the only real argument a priori is the sunk cost argument. What if you look at actual costs and try to estimate how big they are? Sea level rise is a certain cost, but a very small cost, for the reason I just described. Heat waves are going to result in more people dying from heat than before. Those are, I think, the only two fairly definite costs. There are then some possible costs. Going back to the question of other species, what is referred to as acidification of the oceans. And that's a very misleading term, because the oceans are basic. So acidification, the effect of carbon dioxide getting dissolved in the ocean and turning into carbonic acid, is to move the ocean towards neutral. People use the term acidification because it sounds scary, but what you're in fact doing is neutralizing the ocean a little bit. It's a very small effect. But it might be the case that some oceanic species are currently adapted to their current pH, and even a fairly slow change might impose costs. That's, I think, the largest possibility in the sense of the one that I have really no handle on how large it is, but it's certainly a possible cost. The effect on agriculture, there are possible effects in both directions. The general projection is that you will have more rain, but it will be less even. So that means, on the one hand, water more available, especially if people have dams and ponds and ways of storing it, but on the other hand, possibly more floods. That's an argument against it. On the other hand, if you actually read the IPCC report instead of reading the summary for policymakers, which is all that the reporters generally read, one of the very odd things you discover is that they think it's possible that climate change could result in greening the Sahara and the Sahel. That's one which some projections show, some don't. but it's an example of the sort of thing you never come across in the newspaper stories because they are trying to make it all sound horrible, and it in fact isn't. The effect on tropical cyclones is sort of interesting. If you read the summary for policymakers, it tells you truthfully that the projection is that the ratio of high-end cyclones to low-end cyclones will go up. What they don't tell you is that the reason the ratio is going up is that the number of low-end cyclones is going down. That if you actually read the body of the report when it discusses tropical cyclones, the projection is that the number of high-end, which is categories 4 and 5, cyclones will stay about the same. Now, I should say it also is that the average strength of those 4 and 5 cyclones will go up a little bit. So there is a negative effect there. The effect that causes the ratio to go up is the decrease in the small cyclones, which is actually a benefit, which always gets reported as if it were a cost. This is one of the reasons I don't trust the summary for policymakers. As far as I know, it says nothing untrue, but it gives you a very biased presentation of what is true. What about benefits? There is one big benefit that is almost the most certain effect we have, other than maybe sea level rise, and that's CO2 fertilization. Carbon dioxide is an input to photosynthesis. There have been extensive experiments on the effect of increasing the CO2 that crops are grown on. And roughly speaking, doubling the CO2 concentration of the atmosphere increases the yield of C3 crops, I'll explain that in a minute, by about 20%. Doubling is roughly what the IPCC projects for the end of the century. So we're talking, there are more than two, but there are two important mechanisms for photosynthesis called C3 and C4. Most crop plants use C3. C4, the important C4 crop is maize, what Americans call corn. And there are some others as well. Rice and wheat are both C3. For some reason, C3 responds to increased CO2, C4 doesn't, in yield. Both C3 and C4, however, increasing CO2 reduces water requirements. And the mechanism there is very straightforward. In order to do what it's doing, in order to produce the crop or grow it, whatever, a plant needs carbon. It gets the carbon by passing air through its leaves. The higher the CO2 concentration, the less air it has to pass through its leaves. And the less air it has to pass through its leaves, the less water it loses by evaporation. So that's an effect for both C3 and C4 crops. And the basic experimental result is that if the crops are water constrained, then the yield of C3 and C4 both goes up. If they are not water constrained, then C3 crops yield increase and C4 probably doesn't, or not by very much. So that's the reason I say that's the most certain, is that almost all of the projections of the effect of climate change involve a series of causal links. That somebody says, all right, we have more CO2. What'll that mean? It means that less of the infrared coming up from the Earth gets through, and that means the Earth gets warmer. You then need further arguments in order to conclude that there will be more rain, or that the rain will be more uneven, or any of those effects. However, the fertilization is an effect of the CO2 increase. So that's the very first logical step in the process. It doesn't depend on anything else. It doesn't even depend on warming. So in that sense, I think that's a very clear one. A more general effect of the same sort is the greening of the Earth. And again, if you actually read the IPCC report, I don't think this point is ever mentioned in the summary for policymakers, but the report says that the Earth is greening, that the total area of leaves is going up, and that the probable cause is CO2 fertilization, because it doesn't just affect crop plants, it affects trees, grass, everything else. You will have more extreme heat, but less extreme cold. Now, I should say there is a literature on the effect of temperature on mortality. It's not a very good literature, not because people are incompetent or dishonest, but because it's a very hard problem. What they try to do, they've got massive data day by day on the temperature in a city and the number of people who died on that day in the city. And they then say, all right, if temperature at some level increases or decreases mortality, it's not necessarily going to kill people instantly. So we will do a regression, a statistical process, in which we say, how is the temperature on day X related to the number of deaths in the next 20 days? And you can then run that calculation, and you conclude that there is, for any particular location, there is an optimal temperature, a temperature at which you get the lowest mortality, and both above and below that mortality goes up. And there are a number of interesting features of this literature which mostly don't get reported. One of them is that the problem, at least according to their figures, is not extreme temperatures. That the extreme temperature mortality is a small fraction of the total, because extreme temperatures are very uncommon. So that what's going on is, if it's a few degrees above the optimum, but very often, that kills more people than being 15 degrees above the optimum, one day a year, or whatever it is. And the other interesting thing is that deaths by cold are much larger than deaths by heat. And this is, again, a fact that usually it's not get reported, but that is reported in that literature. I should say one thing in that literature is somebody tried to use that process to calculate the effect of climate change so far. It reduced mortality. Now, that doesn't mean it'll keep doing it. Basically, what the literature suggests is that climate change will increase mortality over time. And what's going on there, I'm not sure it's right, but those are their calculations, is that although total mortality is larger from cold, the effect of raising it, you basically have a curve which goes steeply up at the high end and only gently down at the low end. And therefore, when you raise it, you get a more than proportional increase here. So I'm not at all sure it's right. If people are sufficiently curious, I had a couple of Substack posts in which I analyzed a couple of the articles in that literature and tried to figure out what was happening and tried to correct what were, by their own accounts, simplifications. In particular, as far as I could tell, they were not allowing for adaptation. That is, they were assuming that when your city gets 3 degrees warmer, the relation between temperature and mortality stays the same. But you would expect that if your city over a century gets 3 degrees warmer, you are going to be a little bit less likely to go out on hot days. You are more likely to install air conditioning in your house. There will be a bunch of adaptations. And as far as I could tell, they weren't accounting for those. And I tried to do a very rough estimate, which concluded that that would at least significantly reduce, though not eliminate, the net mortality. There's one of the things you also don't mention is the pattern of greenhouse warming is biased in our favor. That if you look at the IPCC maps showing projections, one of the things you notice is that warming is greater near the poles than near the equator. And what's going on is that water vapor is also a greenhouse gas. The more of one greenhouse gas there is in the air, the less the effect of adding another. You can't eliminate more than 100% of the infrared coming up off the Earth. So that means there's more water vapor in warmer climates, hence that the effect of adding CO2 to the air is greater in cold places than in hot places. As a general rule, warming is a good thing when it's cold and a bad thing when it's hot, so that means that the pattern of warming is in fact biased in our favor. Another fairly large effect, which you don't see much discussed, is the increase in the habitable area of the Earth. If you look at a temperature, average temperature map of the Earth, and population density map of the Earth. One of the things you notice is that heat does not reduce population density. That is to say, human beings live in noticeable numbers between about 10 degrees centigrade and 30 degrees centigrade average temperature over a range of about 20 degrees. And you have some of the high-end areas of that are some of the very densely populated areas. The Philippines, for example, is one example. Where you don't see people is where it's cold. So what happens when you raise global temperatures, especially when you raise global temperatures most towards the poles? The answer is the temperature contours shift towards the poles. If you ask what was the line that showed where average temperatures were 5 degrees centigrade or 8 degrees centigrade or whatever it is, that line in the north is going to move towards the pole. That means that if you say, well, average temperatures below so and such, looking at those maps, almost nobody lives there. The area of which that's no longer true has gone up. Now you might say, yes, but all that means is you've got a whole bunch of land which is just barely warm enough to live on instead of not quite warm enough to live on. That's true. But just south of that, you've got land that used to be just barely warm enough to live on that's now a little bit more than barely, and just south of that. So if you think about it, you can roughly estimate the effect by saying, what is the total area of land which shifts from too cold for people to live on to barely warm enough for people to live on, and represent that as the area of good, comfortable land that's increased when you allow for the effect down it. I did that calculation. That's another one of my Substack posts. It's a very rough calculation, what we sometimes refer to as a back-of-the-envelope calculation. Roughly speaking, you increase the useful, at least the temperature usable area of the Earth by roughly the area of the United States. So it's not a trivial effect. It's quite a large effect, which is very rarely included. So the conclusion I'm offering is that there are quite large positive effects. There may indeed be substantial negative effects as well. So I don't want to say that I'm confident that we're better off with climate change, but that in fact it is by no means clear that we're worse off with climate change, let alone badly worse off. Why does everybody believe the opposite? And a lot of the answer is a very biased presentation for a variety of reasons. I mentioned the IPCC summary for policymakers and the effect of the way in which they, without lying, distort the effect on tropical cyclones. The other thing that struck me is the summary for policymakers has this nice map of drought. And it says, here are the regions of the Earth where drought is increasing or decreasing. And they then say, well, here are the ones where we're pretty sure it's due to climate change, and here are the ones where we're not sure if it's due to climate change, most of them. The odd thing is that they show almost all of the regions drought is increasing. One or two it's decreasing, despite the fact that the body of the report says that the Earth is greening. Why is this? Their definition of drought, they're defining it by the amount of water in the soil. But one of the effects of CO2 fertilization is that plants need less water. So if the relevant criterion is not what is the water in the soil, but what is the effect on plants, the former is going to overstate the amount of drought. I do not know whether that, I've not made any attempt to correct for that. I don't know if I have the information to do it. But it struck me as another case in which they were giving a somewhat distorted picture. There's an article that was published in Nature in the last year, which I went over in some detail and wrote a rebuttal to, which Nature did not publish, of course. And the article was an attempt to estimate the total cost to humans of an extra ton of carbon dioxide. They were running this estimate for 300 years, or at least for the next 3 centuries, until 2300. You ought at that point to say then it's probably fraudulent. That is to say, not that it's going to be high or low, but just that so much is changing due to technology. Let me give you one example. Almost half of their total mortality was due to increased mortality when temperatures go up. They didn't mention that they were assuming no medical progress for 300 years. All right? Because when, insofar as temperatures too high or too low increase mortality, they do it by people dying of something. Well, the better the medicine is, the less people are going to die of things. They were ignoring that effect. The article had, I think, a couple of paragraphs at the end discussing reasons why their estimate of the total cost of carbon might be too low. There was not a word about reasons why it might be too high. Although, as I say, that particular one is clearly a very strong reason why it's too high, since it goes through mortality, and mortality is going to go down with medical progress. In my article sort of critiquing it, which you can find on one of my Substack posts, a version of it, I gave at least some examples of the scale of the effect, because you can ask how much has the mortality effect changed over the last 30 years, say, and the answers are quite large. I didn't memorize it, so you'd have to read it to get my effects. Another third thing that I also analyzed was an elementary textbook in climate science called Modern Climate Change by a man called Dessler, who is quite active online. And he has a chapter on the consequences of climate change. It does not list a single positive consequence. It is true that elsewhere in the book he does mention that you will have fewer people dying of cold, but he then says more people die of heat than of cold. He does not give any source for this. It turns out that some of the people who work for the federal agency that deals with diseases did actually do a calculation, and they did it by reading death certificates. And they concluded that about twice as many people die of cold than of heat in the US. However, you don't even have to do that. That is a graph of mortality by month. Does that pattern suggest that people are killed more by cold or more by heat? This is Northern Hemisphere, right? This is the US. And I think the answer is pretty clear, that mortality is up in the cold months and down in the warm months. And that at least ought to be a reason to suspect that warming will reduce mortality rather than increase it. Let me give another bit of my critique of Dessler. I should say the point of my critique is that this is an elementary textbook in its 3rd edition. Any mistake in it has been taught to large numbers of people by large numbers of professors. If there is a clear mistake, either no professor ever noticed it, or Dessler refused to correct it. And that, I think, suggests that climate science is not really a science at present, that it's essentially become ideological. Let me give you another example, and that is he asserts in one chapter that if you take the midpoint of the IPCC projections for 2100, 9% of the land area of Florida will be flooded, containing 10% of the population. And I didn't think that sounded right from what I had seen about effects of sea level rise, so I checked his source. His source was not, in fact, a scholarly article. It was a report commissioned by the Environmental Defense Fund, that is to say, an activist group. However, that source cited its source, which was a journal article by two people, Titus and Richmond. If you followed it through, Dessler's sea level rise that he said had this effect was 60 centimeters. The Environmental Defense Fund, when they gave their figure, was using 68.6 centimeters. And the actual published article it was from was 80 centimeters. What's going on, I should say, what makes this less absurd than it seems, is what they were doing was calculating at the highest high tide of the year what would then reach the elevation of an area. So they were asking basically at the highest high tide of the year, if sea level rise goes up by 80 centimeters, which is a fairly high estimate as it happens, but it's not impossible, how much of Florida will be underwater. But I was also a little surprised by the claim that the percentage of population who were in the relevant area was larger than the percentage of the area, because generally low-lying places tend to be swampy and they aren't where people choose to live. So I looked at, I found the map in the article that their source was drawing on, which showed where the flooding was, and I found a population density map of Florida online. It was quite interesting. If you superimpose them, yeah, this one shows it, you will notice that the areas, most of the flooding is in fact in the Everglades. That's that bit at the southern tip of Florida. Almost nobody lives in the Everglades. And the red areas are the areas which have high population density. And with one tiny exception up north, none of them are in the flooded area. All right, I'm using those black lines are showing the boundary of the flooded area. And the color, you can see over there, there's a key to this. So in fact, it is quite unbelievable that flooding that area could flood an area with that number of people living in it. I have pointed this out to Dessler. I will find out whether he is dishonest or only biased when the next edition of the book comes out. My guess is that he will keep saying the same thing, but I could be wronging him. He was going to have a polite exchange, but his polite exchange led to the conclusion that he knew what the right answers were and was quite confident of them. All right, so let me see if I can make some general points about the basic issue I'm raising is an externalities issue. The basic issue is if putting extra CO2 in the air results in raising global temperatures, which it very likely will. I think there's good reason to believe that's happening. What are the effects on humans? And what are the net effects on humans? It's a complicated question, and it's a question where you're going to make a whole lot of judgment calls. If you know what the answer ought to be, you are going to make all the judgment calls the same way. You're going to say, well, I'm not sure about that. Let's play safe. Let's pick a high number. You are likely, if you notice any positive effects, to make conservative estimates for those for the same reason. And you are likely not to notice some of the positive effects because you're not looking for them. There's an economist who got a Nobel Prize for his work trying to estimate the costs of climate change. And it's quite interesting because if you look at his statements, it sounds as though he thinks climate change is a terrible thing. Then you look at his numbers, like that the effect if we do nothing at all by the end of the century will be about equivalent to lowering the GNP of the world by 3%. Not that the GNP of the world at that time will be 3% lower than it now is, but it will be 3% lower than it would have been if there were no climate change. It'll be like 200% larger, that is the general estimates assume continued growth. That's Nordhaus is the person I'm describing. And there was an op-ed in the Wall Street Journal, this is some years ago, by a group of scientists who were basically arguing that climate change was not the sort of emergency situation that required drastic action. And he wrote a rebuttal. And it was really quite funny if you looked at his numbers versus his words, because what he asked was, according to his estimates, if you waited 50 years to do anything about climate change, how much worse off would you be than if you took the optimal policies starting tomorrow? All right? So that's sort of an upper bound, as it were, of the costs of waiting. And he said the cost of waiting would be $4.1 trillion. Wars have been started over more. This is $4.1 trillion spread over about a century and over about the entire globe. That works out to be about 0.05%, about 1/20th of 1% of global GNP over that period of time. So if you look at his numbers, the effect of waiting for 50 years is trivial. If you look at his rhetoric, it's large. I just noticed I have the quote here. His estimate of the effect of climate change if you do nothing will be 2.5% of world GNP, of world output per year by the end of the century. Couple of other things worth noting. One of them, some people talk as though the temperatures we have or are about to have are unusually high. And that's what period of time you're looking at. That there are comments about this is the highest it's been in the time of human civilization. Might be true, but it's not clear why that's relevant. That after all, human civilization was not subject to the average temperature of the globe. Human civilization existed in a variety of different places. Egypt, which is a pretty warm place, for example. However, a lot of people talk as though it is warm not just in terms of human civilization, but in terms of time in general. And that is, as it happens, not correct. I came across this graph. This is a graph of estimated global temperature over a very long period of time, as you can see. Goes back 500 million years. And you will notice that we're at the low end of it, not the high end of it. That blue color is ice ages. People often confuse ice ages with glaciations. A glaciation is what happens when the glaciers go down from the poles and start covering nice places you'd like not to have glaciers. An ice age is a time when there is ice on one or both of the poles. That's the geological definition. We've been in one for about 3 million years now. And an ice age consists of alternating glaciations and interglacial periods. So, in fact, this is relevant to the people who say, well, look, maybe there's a tipping point. Maybe if the temperature gets a little higher, then it'll somehow will get turned into Venus or something. It'll get much, much hotter. But we know that the temperature has been, I think about 100 million years ago, it was roughly 13 degrees centigrade above what it now is. And no tipping point occurred there. For a lot more, see those sources. I should also mention, since I think I don't think I'm quite out of my time, one sort of neat thing I came across, that if you're being skeptical about this, one of the things that might occur to you is that global warming might be a good thing, because after all, we're in an interglacial. It's an interglacial that's been going for an unusually long time. So maybe it's global warming that's the only thing that's keeping the glaciers from moving south again. It turns out there is, in fact, a respectable theory of this. But the global warming in question is not due to the Industrial Revolution. It started 8,000 years ago with the invention of agriculture. And it's quite neat, because if you look at graphs of a series of interglacials, the normal pattern in interglacial is that during the interglacials, the amount of CO2 is going down. and eventually it goes down enough so that things get colder and you have another glaciation. This interglacial is different. It starts going down and then turns around and starts going up. Well, what happens when you cut down a large fraction of the Earth's trees in order to plant crops because you've just invented agriculture? So that's the theory. This is what's referred to as the early anthropogenic hypothesis. And somebody came up with it about 20 years ago, maybe a little more than that, and serious scholars have debated it back and forth. It's not really an argument at all about what we're now doing, but it does suggest that if we hadn't had the early anthropogenic warming, the next glaciation might be just beginning. That's what the attempts to look at the glacial that looks most like ours in its starting conditions when it ended. All right, so anyway, if you want to see more about this, you can look at my Substack. I was planning to do this from my laptop so that I could then show you what the, actually I bet this thing is connected. I wonder if, is that gonna work? Yes, it's working. Aha, that's my web page. You will notice that it has a link to my Substack posts sorted by topic. As you can see, climate is a large topic, but there are a whole bunch of other weird topics. Discovering truth is one of the important ones, but also economics and education and libertarianism and so forth. And I also have on the web page, at the suggestion of a commenter on my Substack, a search bar. So you can search all of my Substack posts, all of my blog posts, and a large part of my written articles and books using Google to do it for you, which is sort of neat. But if you look here, you will see there is a link to my books. Most of my books in some version or other are available to be read for free. In some cases, the final version, in some cases, a late draft. That's my first book, third edition, and it's a free PDF from the web page. I also have, if you happen to like this talk, I've got a link to my webbed talks and interviews, and there are a lot of them. So if you happen to want to amuse yourself for a year or so listening to my talks, they're there.